In this video, we're going to look at how to rationalize expressions. Rationalizing can be done on either numerator or the denominator. The reason we want to rationalize something is to be able to get rid of any radicals. In calculus, this could be especially useful when evaluating limits. In this case, we have radicals in a denominator, so we're going to rationalize a denominator. In order for us to get rid of square root, we're going to apply the concept that we have seen from before, which is the difference of squares. The difference of squares, a squared minus b squared, is equal to a minus b times a plus b. These are the same except we have difference in the sign between those two terms. We call these conjugates. If we apply this concept, we can then be able to get rid of the radical. Think of this as your a term, and this one is your b term. So the conjugate for this one, right now what we have is a minus b. The conjugate would be the exact same thing except with a plus sign in between. And of course, if it was a plus originally, the conjugate would be with the minus instead. In order for us not to change a question, we need to do the same thing to the numerator, because then essentially this is like multiplying by 1. So now that we have the multiplication by a conjugate, what we want to do is expand the denominator. The numerator, what you want to do is leave it the same, but show your multiplication with brackets. And in a denominator, we have our a minus b, a plus b, which remember will give us a squared minus b squared. You can also look at it as expanding two binomials, which we basically use FOIL. First terms multiplied together, outer, and last. So when we multiply first terms together, square root of x plus 1 times square root of x plus 1, remember that will just be square root of x plus 1 multiplied by itself, meaning it gets squared. And when we square a square root, we end up with whatever is inside, which in this case is x plus 1. So our first terms multiplied together give us x plus 1. When we multiply outer term, we end up with 1 of square root of x plus 1. For the inner terms, it becomes minus 1 multiplied by square root of x plus 1. And the last terms multiplied together give us negative 1 squared, which is negative 1. Now those outer and inner terms end up canceling each other. And this is the reason why we want to use a conjugate. We want to be able to get rid of those square root terms. So now if we simplify further, the denominator simplifies nicely to just x. And now that we have x in the numerator divided by denominator has x as well, we can cancel those as well. And that leaves us with square root of x plus 1 plus 1. Which shows that we don't have any more radicals in a denominator, so we're finished rationalizing. So just a recap, the steps we used to rationalize. First, we had to find the conjugate. Next, we multiplied numerator and denominator by the conjugate. And the last step, expand and simplify. And that's how you rationalize.